In this question, suppose the second charge in the previous problem is minus 1 into 10 to the power minus 6 coulomb. Locate the position where the third charge will not experience a net force. It means that we have to find the position where the equilibrium will exist. So in the previous question, we had two charge body A and B. The magnitude of A was 2 into 10 to the power minus 6 coulomb and the B was 1 into 10 to the power minus 6 coulomb. And the distance between A and B is 0.1 meter. In this question, the charge of A is 2 into 10 to the power minus 6, which is same as the previous question, but the charge of B will change. Now it will become minus 1 into 10 to the power minus 6. And the distance between A and B is 0.1 meter, which is similar to the previous question. So here, if we have to place a test charge, which we consider as positive, so we have three positions to substitute the test charge. It could be on the left side of A, it could be on the right side of B, or it could be between A and B. So if we take the first condition, which is on the left side of A, so A will repel the C because it is a positive charge, and B will attract. But here the distance between AC is smaller than the distance of BC, and the magnitude of A is more than the magnitude of B. So here direction of the force is opposite, but the magnitude of force CB is more than the magnitude of the force BC. So this will form the non-equilibrium between A and B. If we take a test charge, so A will repel and B will attract. So in this case, both will move in the same direction. So it is a case of non-equilibrium. Now in the third position, which is to the right of B, so B will attract C and A will repel. But here B is nearer to C if you compare with A. Even the magnitude of B is less, but the distance is small. So what will happen? Force of BC could be equal to the force of AC. Third position, which is to the right of B, could form the equilibrium. So for that we can take a relation. Force of CB is equal to the force of CA, where right to the B. So if we substitute the value, so if we assume this distance is x, so AC will be x plus 10 centimeter, QB by x square is equal to QA by x plus 10 whole square. So after substituting the value, now it can be written as 2x square is equal to x plus 10 whole square, which is equal to x square plus 100 plus 20x. So the quadratic equation will become minus x square plus 20x plus 100 is equal to 0. So x is equal to minus 20 plus minus root of 20 square plus 4 into 100 divided by minus 2. So from that we will get it as minus 20 plus minus root of 800 divided by minus 2. So x will consider as 20 plus 20 root 2 by 2, which is equal to 10 plus 10 root 2. It will come as 24.1 centimeter.